Hello everyone. Today we will going to see some practice questions from the chapter Chemical Kinetics. This is part 4. Let's start. Disclaimer which says the images used in our slide deck are for educational purposes only. We respect the intellectual property rights of original creators and owners of these images. If you are the owner of any of the images used in this deck and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the images. This is our index slide and we will going to see the practice questions from question number 24 to question number 30. Let's start with the question number 24. The rate of a chemical reaction doubles for every 10 degrees Celsius rise of temperature. If the temperature is raised by 50 degrees Celsius, the rate of reaction increases by about. So we have given that the rate of a chemical reaction doubles for every 10 degrees Celsius increase of the temperature, and if the temperature raised by final 50 degrees Celsius, then the rate of the reaction increased by how much amount? Options are 10 times, 24 times, 32 times or 64 times. You have 10 seconds to solve this question. After that, we will see the correct answer. Okay, let's see. The correct answer is option C, that is 32 times. So for every 10 degrees Celsius rise of temperature, rate is doubled. Thus, temperature coefficient of the reaction is equals to 2, you can say, right? Because it is the rate is increasing by 2 factor, doubled, okay, with the 10-degree rise of temperature. So when the temperature is increased by 50 degrees Celsius, the rate will become 2 to the power 50 divided by 10, because for every 10 degrees Celsius it is raising 2, that is the rate is doubling. But if the temperature is increased by 50, that means we have the rate will become 2 to the power 50 divided by 10, and it will be 2 to the power 5 times. And when you solve the 2 to the power 5, it will be equal to 32 times. Okay. So when the temperature is raised by 50 degrees Celsius, the rate of reaction increases by about 32 times, and thus the C option is the correct answer. Okay, let's move to the next question. Question number 25. The rate of reaction is doubled for every 10 degrees Celsius rise in temperature. The increase in the reaction rate as a result of temperature rise from 10 degrees Celsius to 100 degrees Celsius is. We have to find the increase in the reaction rate when the temperature rise from 10 degree to 100 degrees Celsius. Options are equal to the energy of activation of products, 102 times, 512 times, 614 times. So it is 112 times. So you have these options and you have 10 seconds to solve this question. After that, we will see the answer. Okay. Let's see, the correct answer is option C, that is 512 times. So increase in the steps of 10 degrees Celsius has been made 9 times if we increase the temperature from 10 degree to 100 degree, because initially it is 10 degree, finally it will be 100 degree. So how many times we should increase the 10 degrees Celsius to 10, 10, 10 by the 10? So it will be 9 times. If you increase the 10 degrees Celsius 9 times by 10 factor, it will become 100 degrees Celsius, right? So the increase in the steps of 10 degrees Celsius has been made 9 times, and hence the rate of the reaction should increase by 2 to the power 9 times, because for every 10 degrees Celsius the reaction rate is doubled. So for every 9 steps the reaction rate will become 2 to the power 9. That means 512 times, right? And thus our C option is the correct answer. Okay, let's move to the next question. Question number 26. The role of a catalyst is to change dash. So we have to find that what should from the options, which option suit this fill in the blanks best. The role of a catalyst is to change what? Options are gives energy of a reaction, enthalpy of reaction, activation energy of reaction, or equilibrium constant in a reaction. So you have 10 seconds to solve this question. After that, we will see the correct answer. Let's see, the correct answer is option C, that is activation energy of the reaction. So if you use a catalyst in a reaction, it will increase the rate of the reaction, and the catalyst lowers the activation energy of the reaction. Okay, to increase the rate of the reaction, and the product will form in a fastest way possible. So catalyst lowers the what it will change? It will change in the concept of lowering the activation energy of the reaction happening. Okay, and thus the C option is the correct answer, that is activation energy of reaction. So this will fill this blank, that is the role of a catalyst is to change the activation energy of reaction. Okay, let's move to the next question. Question number 27. For an endothermic reaction, del H, where del H represents the enthalpy of a reaction in kilojoule per mole, the minimum value for the energy of activation will be. So we have to find out the value or the minimum value for the activation energy of a reaction. The reaction is endothermic. Del H represents the enthalpy of the reaction in the kilojoule per mole units. Okay, we have to tell the minimum value for energy of activation of reaction. Options are less than del H, that is less than enthalpy, 0, more than enthalpy, or equal to enthalpy. So you have 10 seconds to solve this question. After that, we will see the correct answer. Let's see, the correct answer is option C, that is more than enthalpy. So the minimum value for the energy of activation will be more than the enthalpy value, that is del H. You can see through this diagram that this is the diagram for any reaction. Here is the reactants, here is the products. This is activation energy of the reaction, this much. Okay, from the highest point to the base, to the bottom of the graph. Okay, this distance is activation energy, and this distance, that is the energy of products to the bottom distance or the lowest point distance. This is known as del H, that is enthalpy of the reaction. And you can clearly see that activation energy is greater than the enthalpy of the reaction in the case of endothermic reaction, and thus we can say that the minimum value for the activation of energy will be more than del H, delta H, or enthalpy, and thus the C option is the correct answer. Question number 28. Which of the following graph represents exothermic reaction? We have to find out that from the graph first, second, and third given, which graph represents an exothermic reaction. You can see that all the graphs are between energy and the reaction coordinate axis, and we have given the plot for the energy of reactants and products and the site for the activated complex formation. You can see that the energy for reactant and product are different in the graphs, in the three graphs. So you have to find out that which graph belongs to an exothermic reaction. Options are only first, only second, only third, or both first and second. So you have 10 seconds to solve this question. After that, we will see the correct answer. Okay. Let's see. The correct answer is option A, that is only first. So graph first only represents exothermic reaction because products have lesser energy. Products have lesser energy than the reactants, which happens in the case of an exothermic reaction, because in this del H is less than 0. So the product will be having the less energy. In the exothermic reaction, energy will release, heat will release, right? So at the product side, the energy is more. At the reactant side, energy is more. At the product side, energy is less, and which you can see in the graph first, that the product of the energy of the product is more, and is less, sorry, energy of product is here, right? So it is less than the energy of the reactant. Energy of reactant is greater than the energy of products, and that is what happening in the exothermic reaction. That's why only first, that means option A is the correct answer. Okay, let's move to the next question. Question number 29. The reaction X to Y is an exothermic reaction. Activation energy of the reaction for the conversion of X into Y is 150 kilojoule per mole. Enthalpy is 135 kilojoule per mole. The activation energy for the reverse reaction Y to X will be. So basically we have given a reaction in which X is reactant, Y is product, reactant is going to product. It is an exothermic reaction, and the activation energy of changing of X to Y is given as 150 kilojoule per mole, and the enthalpy of this reaction is given as 135 kilojoule per mole. We have to find out the activation energy for the reverse reaction of this. That means Y will become product and Y will become reactant and X will become product. So we have to find out the activation energy for this reverse reaction. Options are 280 kilojoule per mole, 285 kilojoule per mole, 270 kilojoule per mole, or 15 kilojoule per mole. You have 10 seconds to solve this question. After that, we will see the correct answer. Okay, let's see the correct answer, which is option B, that is 285 kilojoule per mole. So an exothermic reaction can be represented as this. Energy is releasing, X is giving us Y plus energy. So energy released during the exothermic process. But the energy of Y is very, very less than X, you can see, right? Because energy is really releasing at the product side. So at the reactant side, all the energy is present. So Y energy is very, very less than the X. Therefore, we can say that the activation energy for forward reaction plus del H is equals to activation energy plus for the backward reaction, that is reverse reaction. This we have to find out, right? So we just put the value. We have given the activation energy for the X to Y reaction, that is 150 kilojoule per mole. So 150 plus 135, the enthalpy is given, so 135 is equals to activation energy of backward reaction, that is reverse reaction, and it is coming out as 285 kilojoule per mole. Okay, so we have the activation energy for the reverse reaction, that is Y to X, which is equals to 285 kilojoule per mole, and thus our B option is the correct answer. You can see that the energy diagram profile for this reaction will be this much. X is here, Y is here. It is going from here to here. This much, that is the reactant energy to the bottom line will be del H. The reactant energy to the upper line highest point is activation energy for the forward reaction, and the total distance is activation energy for backward reaction. And this the concept we use here in this equation, that EA of backward is equals to del H plus EA of forward reaction. Okay, and thus B option will be the correct answer. Okay, let's move to the next question. Question number 30. H2O and oxygen atom react in the upper atmosphere biomolecularly to form two OH radicals. Del H for the reaction is 72 kJ per mole at 500 Kelvin, and energy of activation is 77 kJ per mole. Activation energy for biomolecular recombination of two OH radicals to form the H2O and oxygen atom will be. So we have same question, we have given that H2 and oxygen atom react so that OH radicals will form 2 OH. Okay, for this reaction del H is given. For this reaction energy of activation is given. Now we have to find out the energy of activation when the two radicals get converted to H2O and oxygen atom. Okay. Options are 5 kJ per mole, 72 kJ per mole, 77 kJ per mole, or 149 kJ per mole. You have 10 seconds to solve this question. After that, we will see the correct answer. Okay, let's see. The correct answer is option A, that is 5 kJ per mole. So this is the reaction for the forward direction, that is H2 plus oxygen giving us 2 OH radicals. Del H is 72 kJ per mole for this reaction. Similarly, we have asked the EA backward, that is 2 OH giving us H2 plus oxygen. Del H for this reaction will also get reversed because we are reversing the reaction, so it is minus 72 kJ per mole. Again, we apply this equation, this relation, that is EA of forward minus EA of backward is equals to minus of del H. And EA of forward is 77, activation is given as 77, minus EA backward, this we have to find out, is equals to positive 72, because negative will become positive for this reaction. And the final activation energy for the backward reaction, which we have asked in the question, is equals to 5 kJ per mole. 77 minus 72. Thus, the correct option is A option. Okay. Thank you.